Hello and welcome to the ClearPath OS 2200 Release 20.0 update for the Common Internet File System, otherwise known as CIFS. My name is Christopher Korzanowski, and I'll walk you through the latest enhancements for CIFS. There are several new features in CIFS Level 9R3. The Secure Passwords feature adds support for the latest exec password requirements. There is an option to disable SMB1, which is first implemented in CIFS 9R2 IC3. UTF-8 expands Unicode support for the basic multilingual plane via SMB, Xlate, and supported utilities. Let's look at each of these in a little more detail. First, I'll discuss the Secure Passwords Phase 2 feature for CIFS. This feature adds support of the exec's default hashing algorithm introduced by the exec release 20.0 Secure Passwords Phase 2 feature. You must install CIFS 9R3 or later in order to use the new user ID record format. You cannot use older versions of CIFS to map drives to OS 2200 systems using ClearPath Release 20 exec. However, CIFS 9R3 is compatible with older levels of the exec. Next, I'll discuss SMB1 disablement. We actually introduced the SMB1 disablement feature as an interim correction in CIFS 9R2 IC3, since you might not have applied all the IC levels. I'll cover this feature's details here. Two new background run options are now available. These options are D and E. The D option disables SMB dialect versions less than 2.0.2 for both the CIFS server and client. The E option enables CIFS support for the ClearPath extension kit. For reference, CIFS 9R1 was the first CIFS release that supports SMB2 client, while CIFS 9R2 was the first release that supports SMB2 server and client. All levels prior to 9R2 only support SMB1 server. If you specify the D option, the SMB1 negotiate command is still allowed, but other SMB1 commands are discarded. Note that CIFS allows SMB1 by default, unless you specify the D option. Well, how do you disable SMB1? Apply the D background run option by either asking the CIFS administrator to make a copy of the CIFS-back element or modify that element directly. Deactivate CIFS after you've applied the D and/or E options to the @XQT CIFS-back-Z statements. For example, @XQT, D, E, CIFS-back-Z. Now start the modified CIFS-back element to put your requested D and/or E options in effect. This example CIFS-back runstream illustrates applying both the D and E options to disable SMB1 and allow the ClearPath extension kit to properly function. Use the E option to guarantee functionality of the ClearPath extension kit for OS 2200. This is an example of a CIFS server and client with and without the D background run option. We set up a test system with an IP address of 10.0.0.0 to support only SMB1. We also set up an OS 2200 with an IP address of 10.0.0.1. Without the D option, the CIFS server and client connect to the SMB1 system. The Wireshark trace shows that an SMB1 dialect is selected. Notice how SMB1 traffic is contained in the Wireshark trace. The D option prevents the CIFS server and client use of the SMB1 dialect. The top right-hand side of this slide shows that CIFS did not accept additional SMB1 commands beyond the initial multi-protocol negotiate request. Notice the errors indicating the server does not support the SMB1 dialect and the client is unable to connect to the desired network path. Lastly, we'll discuss the UTF-8 support feature for path names and touch on XLate enhancements. UTF-8 is the dominant encoding for the World Wide Web. CIFS now supports UTF-8 path names and character set translation. We'll cover how to enable UTF-8 path names, show examples of path names, and touch on XLate enhancements. You can use new profile variables of lang and LCC type along with the variable setting of UTF-8 to enable this new encoding. How do you enable UTF-8 path names? Enable UTF-8 path name support by either updating the passive system profile file or by using the CIFS background run console keying to set LC all to UTF-8. You can use new passive profile variables LCC type and lang to statically set the system profile file. If you have write access to the system profile file, then you can set LC all, LCC type, or lang to be equal to UTF-8. Note that LC all will take precedence over LCC type, and LCC type will take precedence over lang. An example line in the profile file shows how case-sensitive lang is set to UTF-8. Restart CIFS to make your desired static profile settings take effect. Use a background run console keying to dynamically enable UTF-8. This option affects subsequent CIFS connections. Set the case-sensitive LCAll environment variable to your desired encoding. This slide shows an example in which the CIFS environment variable of LCAll was set to UTF-8 in cons mode. CIFS displays path names in ISO 8859-1 by default, unless you specify in a coding. UTF-8 is a variable with order-dependent Unicode encoding consisting of 8-bit bytes. CIFS supports the basic multilingual plane, so allowed UTF-8 byte sequences do not include the 4-byte variations. If your path name contains any invalid unordered encodings, such as the 4-byte character surrogate pair range, D800 through DFFF, then you'll see a replacement character, which is a white question mark inside a black rhombus for each instance. You can use UTF-8 to improve multilingual readability. See the lower left-hand side for an example OS 2200 directory that contains various UTF-8 path name encodings via SMB. See the lower right-hand corner for an example of a CIFS utility ls-l command performed on the same directory from PuTTY. Use multiple byte UTF-8 characters beyond the qualifier style file name level or outside of the /OS2200 directory. We also enhanced Xlate utility and APIs to support UTF-8. You can use coded character set CCS translation names of UTF-8 and UTF-16 for either the utility or APIs. For reference, the CCS name of UTF-16 is equivalent to Unicode. You can use Xlate directories to translate various character sets to and from Unicode, UTF-16. SDF files written into the local directory use the in setting to convert data from the specified CCS name format into Unicode. Likewise, files read out of a translation-enabled local directory use the out setting to convert Unicode to the specified CCS name format. This slide shows an example of the CIFS Xlate command as well as a CAPI example call. This concludes our presentation. Thank you for watching. Have a great day.